All right, we'll look at question number 4. Anda is a teacher in Zambia. We shall use annexed that shows the detailed layout of the school building where it teaches. Use the information in the annexure A in annexure D to answer the questions that follow. Write down in simplified form the ratio of number of single doors to the number of double doors on the school layout plan. Ratio. All right. So now if you write a ratio, remember, they want us to get the number of single doors to the number of double doors. Shall go to the next year and we look for that. So here we shall come and look for the double doors. We count them. The double door to take this much. This is how it will look like. Let's count. You see, 1, 2, 3. We have a 4 here. Double doors, 5, 6. That marks the end of the double doors. All right. Double doors, we have 6 of them. We have 6 double doors. 6 double doors, that's what we have. 6 double doors, that's what we have. And you said 6, all right. Then we go and count the single doors, which will be, let me count them in a different kind of ink. Single doors we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Then we have 30. So there are 30 single doors. 30 single doors. 30 single doors. So single doors we shall write there and you say that in single doors we have 30 of them. And we shall write it down and say that June 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So there are 30 doors. So we shall come here and say we have that, but they said in simplified form. So we can say we can divide through by the smallest number there, which will give us 5 is to 1. For every 5 single doors, you have 1 double door. That's what simply means. That's what it simply means. Name the rooms that have 2 double doors and 1 single door. 2 double doors and 1 single door. The rooms are Two double doors, we have one and there, a single door it's here. So the room there, then you also have this double door and one single door. So the rooms are, one is the reading room and the other is a computer lab. The same reading, the reading room and the computer lab. Set one feature that indicates that the school has more than one level. These will be the stairs. Stairs can be found with the same level. Stairs are found where we have more than one floor. So the feature that shows, we are looking and you're saying it's the what? The stairs. Take note, what else would show this? We talk of the lifts, or you would have talked of elevators if they were there, but there's nothing like that. So the answer there is what? Stairs. We have it as stairs. During the eviction drill, undertook the following route. 1, exit the room, turned left into the hallway, went straight past 3 single doors, past 3. Take note of that. 3 single doors on the left and a fire extinguisher on the right. So this is the key icebreaker here. 3 single doors on the left and a fire extinguisher on the right. Turned right at the end of the hallway, past 2 rooms, each having double doors. Then used exit to use in the case of what? Fire. All right. Determine the room from which hand is coming from. It passes now. Look here. What you have to take note of is that he turned right at the end of the hallway and he finds a room, 2 rooms. They're saying 2 rooms with double doors. 2 rooms with a double door. Okay, let's go to that. When you look at it critically, first and foremost, we need 2 rooms with double doors. 2 rooms with double doors, because this is called problem solving. Where do we start from? 2 rooms with double door. 2 rooms with a double door. All right, and this was on his right. So 2 rooms with the double door rooms are here. There's one. These are the 2, you see, and they have double doors. Each has one, and there's a fire exit place here in case of fire. Exit to use in case of fire. It's here. That means if the person exited from here, now we need to go back and see where are the 3 single doors. You see, 3 single doors on the, because it was coming like this. It was heading like this. So on the left there are 3, and there's a fire extinguisher here. Fire extinguisher there. So it's coming from this other room here. You see that? So if it's coming from this other room, this could be the room. Because after that, he turns, because on the left, because this is his left and this is his right when he's moving like this. So on the left, there are 3 doors, single doors. On the right, we have a fire extinguisher. It turns right in the hallway. It passes rooms with single door. So we've identified it and the fire. So it was coming from where? From the staff room. From the staff room. The laboratory floor needs to be retiled. The dimension of the tiles that will be used are 600 millimeters by 600 millimeters. This, once you see this, you just know that this is what? It's a square. Both sides are equal. Then they are in five, okay, there are 5 tiles in a box. So in one box has 5 tiles. All right. So this is the floor plan of the lab or laboratory. Okay. The science teacher claimed that they would need a minimum of 40 boxes. A minimum of 40 boxes. This simply means they can even have 60 and above, but they meet the starting point. They should not go below 40 boxes. So here we go. So this simply means if you get your answer and it's 45, the claim is valid. If it's 70, the claim is valid. If it's 80, if any number 40 and above to be valid. But if it's below 40, then it's invalid. Let's find out. The minimum of 40 boxes of tiles to tile the laboratory floor if cutting and breakages are ignored. Verify showing all calculations. If his claim is valid, use a formula area of a rectangle equals to length times breadth. Now, they have given us even the formula, but there are 2 methods of doing this. I'll start with the first one. I'll start with the first one, which say whereby we consider, because now, first and foremost, we are not buying tiles one by one. We need to know how many tiles do we need. And how many tiles do we need? We shall start with, we shall say, number of tiles will equal to the area to be tiled, divided by area of only one tile. Area to be tiled. Now, when we come here, this is the area to be tiled. This shape is irregular. It's not, so we divide it to make it regular, in that we have side A and B to make sense out of it, because we are finding the area to be tiled. So we shall say we have A. So we say area in A will equal to L times B, which is the length is 11 times the breadth, which is from here up to there. If from here up to there, it's 7. Yet from here up to there is 30,5. That means also here it's 30,5 meters. So our breadth becomes 30,5. We multiply there. We get our answer. As 11 times 30,5. We have our answer as 38,5. These are meters what? Squared. Only for this part. Only for that part there. All right. Then we continue and we shall say part B, it's this other side. So area of B, that's what we're going to look for. So area of B will also be straightforward. We shall say area of B will equal to, already you've mentioned length times breadth, there's no need. So our length is 14 times 3,5. We are looking at this section here. We're looking at that section. So 14 times 3,5, we shall say the answer there, we get it as 49. These are meters what? Make sure that the units are the same. So the total area to be tiled, total area of B, area of A plus area of B. Area of A plus area of B, which is 38,5 plus 49. 38,5 plus 49. So the total area there to be covered, it's 87, 87, 87.5 meters squared. Okay, so this is area. Now we look for the area of the tile, area of only one tile. So area of only one tile, allow me to do this, but I remember the measurements are in millimeters. Let's first change them to meters because our area that we found it's in meters. So this simply means it's 0.6 meter by 0.6 meter. So area of only one tile, it's L times that, which is 0.6 times 0.6. 0.6 times 0.6, which is 0.36 meters squared. So here, now we come back to our formula here, we shall say. The area to be tiled, it's 87. Divided by 0.3. So here the answer became the number of tiles that we need. But this simply means you can't buy a half, but you need more. So you make it 244 tiles because we need more. We need more. So we don't stop there. So we found out that we need 244 tiles. So we need to pack them in boxes. Each box takes 5. So we shall divide this by 5. We divide this by 5. So you've got 48, comma 8 what? Boxes. But remember, you can't buy a half a box. So these are 49. Minimum. So the statement is what? The claim is valid. Minimum of 40, which you got 45. 49, sorry. Okay. Let's use the method. But I think this one, it will be the one because they have told you area of a rectangle. This formula might be used. So we got the area and we got that much. The other method would have been finding out how many feet on the long side, how many feet on the short side. So when we look at this, still in B, we shall say we have 14 divided by 0.6. Then still same measurement, we have 30.5 divided by 0.6. How many are they? So 14 divided by 0.6, here we have 23. 23.33, so full tiles are 23. Then we have 0.5 divided by 0.6, whereby we have 5.83. So here we have 5 full ones. So on side B, this side here, total number of tiles that we need is 23 times 5. 23 by 5. Here we need 11. Keep them aside. Let's look at A. Let's look at side A. How many tiles will fit on the long side? How many tiles will fit on the short side? Then we multiply, afterwards we shall add the tiles needed in A and B. The reason why I'm using this, it's when this is how we budget for some space that will be left behind. Okay, we continue and we say, now A, side A, this one here. So how many will fit? How many will fit? So we shall say on the long side you have 11 comma divided by 0 comma 6 because these are the same tiles. By the way, okay, it's fine. 11 divided by 0.6, you have it is 18 comma 3333. So we have a maximum of 18. But then remember, on the short side is the same as this, so also short side. So in A, we shall need 18 times 5. 18 times 5, whereby we get to the 90. So the total number of tiles we shall need 115 plus 90. And the answer becomes we need 205 divided by 5. We have 41 blocks. Okay, we continue. 4.2. Anda uses a strip map in Annexure E to plan his travels. Annexure E shows a strip map of roads connecting Zambia to South Africa. Use the information in Annexure E to answer the questions that follow. Write down the total number of countries shown on the strip map. All right, this is a strip map that we are looking at. We're going to look at the number of countries shown. Number of countries shown, we have Zambia. This is 1, Zimbabwe, 2, we come to Botswana, 3, and lastly we have South Africa, 4. So the countries shown is supposed to be 4 countries. Name the town that is 403 kilometers from Bulawayo. Come look for Bulawayo. This is Bulawayo. This side it's 15 plus. On the right hand side it's with what's the next town? Next time is that much. Supposed to be here we go. And they traveled from Victoria Falls to Bulawayo. He had to pick up a friend from Songwe National Park before reaching Bulawayo. And they left Victoria Falls at 5 minutes to 10, that's AM, and traveled at an average speed of 97 kilometers per hour to Songwe National Park. So determine the nearest minute at which he reached his friend. You may use the formula below. So now we are nearest minute. Determine to the nearest minute what time he. So we are determining that time. Okay. So first and foremost, time equals to distance over speed. Do we have the distance? The speed is already given. All right, then we go. Let's go and check. We need the distance because the speed we already have it, but the distance we don't have it. We shall come to the distance. She can come to the map here and analyze. So the person travels from Victoria Falls. They have to come here. So from Victoria Falls here to this, how much distance has been covered? Okay, that's what we are looking for. So we shall say, we shall subtract this from this. So it's 700 313 minus 552. 313 minus 502. So the distance covered is 161. But this is on the road, the national park. Sorry, the national road. Then, if they branch off to the national park, they will add on what? 18 kilometers. So we shall also add on the 18 and we end up having this is the distance covered. All right. So we shall go the other side and look for the time. So the distance, we've already seen it. Distance, we are saying it's the same as 179 kilometers. So the distance 700 divided by the speed. The time got here, it's 1 hour. Okay, let me do it. You get, when you divide this, you get 1,8 4 or 5, and you know. So this is 1 full hour. The one represents hours. Then 0,84. These are also hours, but not full hours. So we need to change them. If we remove the one remaining with 0,845 times 60, we need it in minutes. So it's 1 hour. One hour, then 51 what? Minutes. All right. Then they're asking us, because they determine the time to the nearest minute at what time. So it's 1 hour, 51 minutes. So calculate the total distance he traveled from Victoria Falls to Bulawayo. Remember, from Victoria Falls, it goes to the national park. Then, you branch off there from the national park. He comes back to the national road and he drives to Bulawayo. So we need to know the distance from there up to there. Supposed to be 179 plus another 18, because he has to drive from the park to the national road. Then we need to look for the distance from the national road to Bulawayo. We shall come here. What's the distance now? Now we are starting from here, because this was already covered up to here. Up to there. So we shall need to subtract, which will be 52 minus 26. So 552 minus 630. We have this much, but you should also add the 18. I'm moving this other side like that. Plus 18. The answer here becomes 307.